On the continental United States, an average of 30 inches of precipitation falls each year. That amounts to the entire annual flow of the Mississippi River 10 times over. Yet America, even with its abundant supply of fresh water, has serious water problems. One of these is that rainfall is not uniform throughout the land. In the Southwest, the average is only 10 to 20 inches a year. Because of this, water is precious, and whatever sources are available are sought out and fought over the several states. The most important of these sources is the Colorado River. At Parker Dam, a good part of its water is diverted to Southern California. This pumping plant lifts the water and starts it through a 700-mile distribution network of tunnels and concrete-lined canals to try to meet the needs of 6 counties containing more than 10 million people.
You don't have to look around very long to know why we have water problems in Southern California.
Every day there are more people
requiring more homes,
more food,
and more jobs.
We raised vast quantities of food here in California, but we couldn't do it without irrigation water. With increasing demands, there are times when we can't get water when it's needed most.
Now let's hear from a few other witnesses.
Sure, they've got problems in California, but what about us in Arizona? You can argue who's right all day long and not come to any conclusions. The recently authorized Central Arizona project will give us more water, but that's not enough to meet future needs.
After all, most of the water originates on the western slope of the Rockies here in Colorado, and we need some of it for our dry but fertile soil on the eastern slope. We can sympathize with Arizona and California's water problems, but we have them too.
You Americans must remember that Mexico also has a claim to Colorado River water.
By compact in 1922, Mexico was promised 1.5 million acre-feet of water yearly. But more promises were made for its runoff than the river can fulfill.
So what's the solution? Sure, we can all claim we've got a right to more water, but the fact is the Colorado just doesn't have enough of it to satisfy those claims. And I'll tell you, the only solution is to pipe in water from the Columbia. Up there, they got plenty of water.
Plenty of water? Yeah, now we do. But what about the future? The Northwest is one of the fastest growing regions in the country. And what happens when the place gets crowded? I'll tell you, we'll need all the water we can get, and then some.
And so the struggle for more water in the arid Southwest continues. Meanwhile, the population continues to grow, promising even greater demands for water in the future. Where is this water going to come from? Dams are part of the solution. More dams to store the available water, and more aqueducts to transport the water where it's needed. Here at San Jose, California, water is being stored by means other than the building of a dam. In the past, 2/3 of the water that fell on this area would run off, cause floods, and then discharge into San Francisco Bay. To save some of this water, recharge or percolation ponds were developed, which allow stored water to filter through layers of sand and gravel to the underground. The result of this operation has been to raise the water table in the area, a trend quite the opposite of what is generally happening. The Southwest lacks fresh water, but nearby, as in many arid regions of the world, vast oceans of water exist that could supply all the fresh water needed. The problem, of course, is removing the salt. Pure water can be made from salt water by a process called distillation. In this flask is a solution of salt water. The water boils, changes to a gaseous state, and is condensed in this cooling coil. Salt and other impurities remain behind. The distilled water is now fit to drink, but this is a slow process. Distillation will take place more quickly and at lower temperatures if we decrease the air pressure above the salt water. When a vacuum pump lowers the air pressure in the flask, some of the water boils instantly or flashes into steam. Using less heat, this method of distillation is a faster and more economical way of producing large quantities of pure water. A distillation process similar to this is used here at this desalination plant of the United States Department of the Interior in San Diego, California. The raw material for this conversion is salt water taken from the ocean. It is piped to these distillation chambers. After heating, the brine flows into the first distillation chamber. In the partial vacuum, some of the salt water flashes into steam, which condenses when it comes in contact with pipes that carry in the unheated salt water. The brine then flows into other chambers, where it flashes under a pressure lower than that in the previous chamber. The salt-free condensed water is collected, and the brine from the final stage of this process is returned to the sea. The method of desalination employed in this plant is called multi-stage flash evaporation. 2.5 million gallons a day of fresh water are produced here. Other plants for desalting seawater are already in operation throughout the world. In the future, plants using nuclear energy could make desalination more economical. These plants would produce both fresh water and power. Changing the weather is another way in which the problem of water scarcity is being attacked. Seeding clouds with dry ice dropped from aircraft is one way in which weather can be modified or precipitation can be artificially induced to supply additional water from the atmosphere. Another way is by the use of ground-based silver iodide generators. Under the right meteorological conditions, cloud seeding will increase precipitation. While efforts continue to increase the water supply in arid regions, we are also experiencing a problem of another sort in many areas. This is the problem of water pollution. Water is polluted by sewage, by wastes of industrial processes, and by pesticides. These materials contain organic and inorganic chemical compounds and a variety of harmful microorganisms. When these compounds decompose, they act as nutrients which over-enrich the water and promote the growth of small underwater plants called algae. Decaying algae rob the water of oxygen, destroying aquatic life and preventing the water from purifying itself. When ingested, other waterborne wastes may affect man because they are toxic. Some bacteria, when ingested, can cause disease. This is Lake Michigan, one of the 5 Great Lakes, which together form the greatest connected area of fresh water on Earth. Though the states bordering the lakes would not seem likely victims of a water problem, nevertheless, they are. For though the lake water is not being exhausted, it is being polluted. Steel mills and oil refineries are among the worst polluters of Lake Michigan. The pollution from these plants has affected the entire southern end of the lake. In many communities, insufficiently treated sewage and industrial pollution periodically put the beaches off limits to swimmers. In the waters of Green Bay, to the north, the pollutants are raw and partially treated wastes from paper mills and the cities along its shores. Bacteria feed on these wastes, robbing the water of oxygen. Moving east, Lake Erie is almost biologically dead. That is, desirable aquatic life can no longer survive here. Only algae and various scavengers find the environment hospitable. The story is depressingly similar in many other parts of the country. New York's Hudson and East Rivers are open sewers. The Cuyahoga River in Ohio is so loaded with the waste products of petroleum distillation that it is actually in danger of catching fire. Even the tidal areas adjacent to cities and towns are becoming polluted. Clams and oysters from these waters cannot be gathered, except in legally designated areas, because they have been found to harbor bacteria from the wastes in rivers flowing into the estuaries. So, with many of our water resources becoming polluted, how are we going to provide ourselves with sufficient quantities of water that we can use? We can obtain pure water from polluted water by purification processes such as those used at Lake Tahoe, California. In the Lake Tahoe plant, the primary and secondary treatment given the incoming sewer water is similar to the kind provided in most sewage systems. Settling tanks permit sedimentation of the larger solid particles. In this demonstration, you can watch sedimentation in raw sewage water with the help of a time-lapse camera. The sewage water is then aerated to hasten decomposition of the waterborne excrement. Then the water passes into another settling tank, from which it emerges looking like the end product of most sewage treatment plants. In this plant, however, the water passes on to several further stages of treatment. Here, powdered lime is added as a coagulant to remove phosphates that algae need for growth. When lime is added to phosphate-rich water, the lime combines with the phosphates and they precipitate out as calcium phosphate. After another stage, which removes dissolved ammonia gas, another algae nutrient, the water passes through several layers of gravel and sand in these filter tanks. Filtration also removes suspended solid materials, as you can see in this demonstration. Now, filtered, the water is clear, but it still has another stage to pass through. These tanks are filled with activated carbon granules, which absorb still more chemical and biological impurities. The water has now been treated to a stage pure enough for drinking. Only a small amount of nutrients and trace elements remain. Before it is stored for use, however, chlorine is added to prevent the growth of bacteria. The water reclamation system at Lake Tahoe is a pioneer effort in the kind of complete sewage treatment that will become increasingly necessary throughout the country as growing population and industrial output continue to add to the pollution of our freshwater resources. At the same time, more fresh water will have to be extracted from the sea. In the future, we are going to need more and more fresh and unpolluted water. The task of satisfying that need will require greater and greater expenditures of money and strict local, state, and federal controls. Different parts of the country will require different means of water conservation. What kind of water problems are there in your area? How will these conservation problems be solved?